This is a look at the fourth grade standard on quadrilaterals. What I'm going to do here is a series of steps. This video is designed for teachers to teach a particular lesson. We'll start with an 8.5 by 11 sheet of paper, and we're going to fold it in half and half again so we can get some creases that look like this. We can then put this on top of a stack of other sheets of paper and then cut it on a paper cutter so we get each of these separate rectangles down like this. So that's the pre-preparation part. Now, if we look at this rectangle right here, for instance, we're going to say the students will all get multiple rectangles. So we'll start with the rectangle. We need to define what a rectangle is. A rectangle is a quadrilateral with 4 right angles. So you can see this is a rectangle. We could, if you want to have the kids glue these in a notebook, that's fine too. We've got the 4 right angles right there. We can write the word rectangle on it. Now, we also can note, and again I'm using symbols here, 2 lines here, 2 lines here. It's a rectangle, so these sides have to be once we have the 4 right angles, these have to be congruent, and these have to be congruent. So that's our rectangle. Now the next one we're going to look at is a square. What's different between a square and a rectangle? A square, we'll again start with a blue rectangle. I'm folding this side down to match this edge down here. Then I'm getting a pair of scissors out. I'm cutting along that edge. I didn't cut perfectly, but it's close enough for our purposes. I unfold it. Notice again, we have the 4 right angles. Again, the students can make these little right angle marks. And because it's a rectangle, we know these sides are the same. Now, since I fold this down and match this up, I can also see that these sides are the same. So if we compare the rectangle and the square, we can say that the square is a rectangle because it's got the 4 right angles, but the difference is the sides are now all the same. So this is a little more specialized than this. Now we're going to talk about a parallelogram that's not a rectangle. Again, we start with one of the blue rectangles. There are a couple of ways to do this. I'm going to do this one particular way. I'm getting a ruler out, and rulers are important and useful tools. I'm going to place the ruler so it touches the vertex. See down here in the corner? And then it's going to come up at an angle, not too far in. The angle doesn't matter. See, I do that little line there. I'm going to fold it before I cut it. I'm going to cut this off in a minute. Take this line right here, and I'm going to cut it on. I'm going to cut along that line. I'm going to take this rectangle, this triangle, I'm going to flip it over. I'm going to flip it over. See, there it is. It was right here. Flipping it over once, flipping it over twice, and placing it over here on the other side of the piece of paper. Placing it right along the side. Then I'm drawing the line along this edge. And I'm going to fold that in. I could also cut that off, but I'm just going to fold it in for right now. Now, I've got a parallelogram. Because of the way I made it, see the lines? These lines are going to be the same length because I made them from this piece. And more importantly, they're going the same direction because the triangles are the same. So they are going to be congruent, but they're also going to be parallel. And these little arrows for parallel over here. I could do that too here, but it's separate. So those are parallel. These were already parallel, so they got to stay parallel. This side and this side will also be congruent because I cut off the same amount. So I've got a parallelogram now. There's another way to make a parallelogram. I could start with, here's my rectangle. I'm going to place a ruler so that this ruler touches one vertex of the rectangle up here in the corner. And this, and the other side of the ruler touches the other vertex. Again, I'm holding this down really hard. I'm going to draw along these with a pen. Now, since the opposite sides of a ruler are parallel, I cut along those lines. This is also a parallelogram. We know these sides are parallel because they were made by the ruler. Arrow, arrow. They're also congruent. This is congruent to this. So this is another way to make a parallelogram. So we've now seen this. Now, before I go on to the last couple, I want to point out the advantage. Many cases we think of this lesson by giving them lots of examples. In this case, we're focusing on a few examples, but done slowly so the students get a better understanding. We made two parallelograms. They don't look alike, but they're both parallelograms. We made one square, one rectangle. Now we're going to go to a rhombus. Rhombus is a little trickier. There are several ways to make a rhombus. We're going to do it one particular way. I've got my rectangle again. I'm folding it side to side. This is to find the midpoints. I'm going to unfold it and fold this side to side. I'm actually going to leave this folded. I should do it. So I folded all this. I've now folded the rectangle twice. I'm now just going to draw the diagonal of this rectangle, this folded up rectangle. Just draw the diagonal, that's all I'm going to do. And then I'm going to cut down that diagonal. Now, something that's true about a rhombus is a rhombus has two lines of symmetry. And I've actually used that property to make this rhombus. So this is a rhombus. It's kind of a sloppy one, but it's okay. But it's going to have two lines of symmetry. I can match up the sides to see that the sides are going to be the same. These two on top of each other, these two on top of each other, and clearly see that this and this are the same. And then when I fold this over, this and this are the same. So this is a rhombus. It doesn't have right angles. It could, in which case it becomes a square. But a rhombus doesn't have to have right angles. If I wanted to, I could actually neaten this up and I could have cut this angle at a different angle and still have a rhombus. I'm going to recut this just because I feel like it. So if I were to do the two folds and cut it like this, unfold it, still a rhombus. Sides are still the same lines of symmetry. So now we've made a rhombus and we can actually see it, what it looks like, and we've used some of those properties the kids should have a vague feel for to make each of these figures. All that's left are trapezoids, and there are many ways to make trapezoids. This is a little part of the rectangle I cut off earlier to make the square. Again, I'm using my ruler a lot. This is not an accident, because rulers are something students have a lot of familiarity with, and the more work they do with them, the better. I just drew a single line here. I'm just going to fold this back. We now have a trapezoid. What's a trapezoid? A trapezoid is something that has exactly one pair of parallel sides. These sides are parallel, these sides aren't. So that's a trapezoid. Now, there are other kinds of trapezoids. You're going to take another, fold it in half. I'm actually going to cut this one rather than do any drawing. If I unfold this, I have what's called an isosceles trapezoid, because I use the line of symmetry to make it. So again, these are trapezoids. The sides are parallel. We don't necessarily know anything else about it. I can obviously make several others if I want to. I hope this was helpful in looking at the quadrilaterals in 4th grade.